Hi friends, in this session we will study about the matrix. It is an array of elements in rectangular form. In a bracket is called the matrix. It is only the arrangement, we cannot find out the value of matrix. It is just the arrangement of elements in rectangular form. So we could put in any sort of matrix, any sort of bracket we could put the elements in a rectangular form. We can take a bracket like this bracket. We can take this bracket also, large bracket, this medium bracket we can take, okay, or we can use two vertical line here and two vertical line here. We could put the elements between two vertical lines. This would be the matrix. So the matrix we could represent in this way. First of all, I would like to tell you about the matrix. I explain you one of the matrix. The matrix A. We are making a matrix one. This is the element A11, A12, A13, A21, A22, A23, A31, A32, A33. You see here, if the matrix A we are showing with the element A. A11 means the first row, first column, first row, second column, first row, third column. First first number represents the number of row, and the second number here represents the number of column. Second row, first column, second row, second column, second row, third column, and so on in this way. So this is the rectangular matrix of 3 by 3. Basically it is a square matrix because of order 3. Here the order of matrix M is to N. M is number of row, M is number of rows, and N is number of columns. Okay, so first we have to write the number of rows, then number of columns. So here in this way we could represent the matrix. If we have a matrix like this, 2 1 0 5 9 minus 1. So we could find out the order of this matrix. There are 2 rows and 3 columns, 1 2 3. So 2 by 3 order we have of this matrix. Now you are well aware about the order of the matrix and value of the matrix. We could find out the position of element. It is the 1 1 1 2. This is the position of the elements in the matrix. Now I explain the type of matrix. Types of matrix. You see here, types of matrix. So types of matrix, if we see, the first I would like to explain you row matrix. Row matrix where M is equal to 1. The number of row is 1. Okay, number of row is 1. So I explain you this here. You see 1 minus 2 5. The number of row is only 1, then the column are 3 and row is 1. So this is the row matrix. Number second, column matrix. Column matrix where number of column is 1. You see here minus 3 minus 2 0. So this is the column matrix. So number of column is 1, number of row is 3 here. Number third, rectangular matrix. In rectangular matrix you see m is not equal to n, number of row is not equal to number of column, is called the rectangular matrix. So just like 1 3 5 7 0 2, so there is 2 row and 3 column, m is equal to 2 and n is equal to 3. So m is not equal to n here, you see. So this is 2 by 3 matrix, rectangular matrix. This one is also rectangular matrix, this one is also rectangular. The order of this matrix is 1:3, 1 by 3, and order of this matrix is 3 by 1, the 3 row and 1 column. So these are all rectangular matrix. Now we see fourth one, square matrix. In square matrix, where the m is equal to n, number of row is equal to number of column, is called the square matrix. So just I write here one matrix, you see 2 minus 1 5 7. So you see here m is equal to 2 and n is equal to 2, so it is the order 2 by 2, so it is a square matrix. This is the square matrix of order 2. Now we see the diagonal matrix. In diagonal matrix, it should be a square matrix. In diagonal, if it is a rectangular matrix, so there won't be a diagonal matrix. So diagonal matrix is the sub matrix of a square matrix. So I explain you -3 0. Oh, just a moment, I change the color here. I use this -3 0 0 0 1 0 0 0 5. You see there is a diagonal is here. This one is diagonal, you see, and the element, the value, having some value in the elements except diagonal, there are the value of other elements are 0. So it is called the diagonal matrix. So you can see that there are two diagonals. One diagonal is this and the other diagonal, you see, I explain you here. You see another diagonal is like this. This one is also a diagonal. So why we take always this one is principal diagonal? Why? Because the first element and last elements are there in this diagonal. You see, I explain you here where you have seen here the first element and last element are here in these diagonals. So it is called the principal diagonal. This one is not the principal diagonal. So we say the diagonal only to this, not to this. So this is the diagonal. Except diagonal, the value of other elements is 0, is called the diagonal matrix. Now we see the scalar matrix. Number 6, scalar matrix. Scalar matrix is also the sub matrix of diagonal matrix and square matrix. 5 0. Oh, I changed the color here again. I put this color now. 5 0 0 0 5 0 0 0 5, where the element of diagonal are all same, having the same value, and the other than diagonal all are 0. So this is the scalar matrix. Here you see the difference between diagonal matrix. It is also a diagonal matrix, but the value of all elements of the diagonals are same. All the elements of the same value is there of each and every element in the diagonal. The other elements are 0 there. So it is the scalar matrix. Number 7, I would like to tell you about identity matrix. Identity matrix. So in identity matrix, you will see you see here 1 0 0 0 1 0 and 0 0 1. This is the identity matrix. It is also some matrix of the scalar matrix, some matrix of the diagonal matrix, some matrix of the square matrix. So here you see in the diagonal the value of all the element is 1. It is unique, and other values are always 0, just like a diagonal matrix. So it is called the identity matrix. So this is the identity matrix where the element of the the value of the elements of the diagonal is same, is 1, is unity, and the other elements are 0. So this is called a identity matrix. Now we have seen these matrices here. Now I would like to tell you some other sort of matrix also. The 7, now we see the 8th one. So in 8th one we see there is null matrix. Null matrix, where the value of each and every element is 0, is called the null matrix. It may be rectangular or square, both. This is a null matrix. So this is called the null matrix. Now we see, first of all I would like to tell you about the transpose of a matrix and negative of a matrix. We see first here the transpose of a matrix. It is the 9th one. We have transpose of a matrix. Transpose of a matrix, if we have a matrix like I explain you one example here. If we have a matrix here 3 minus 2 4 5 9 0 4 1 3, we have this matrix. Sorry, just a moment. We have this matrix and we have to make the transpose of this. So we will explain by this way. A transpose, A days or AT, we can write A T, we can write A T. In this way we can symbolic this, and we find the transpose of this. We have to change row into column and column into row. So you see the first row I put as a column here. So I get here 3 minus 2 4. This row I am putting as a vertical form. This row again here nearby this 5 9 0, and this also 4 1 3. So this is the transpose of A. Okay, this is called the transpose matrix. Now I would like to tell you one more thing about the negative of a matrix. Negative of a matrix. Negative of a matrix. So just we take this A here, and I would like to make the negative A. So what I have to do? I have to multiply a negative in minus in all the elements. So it would be like this. 3 minus 2 4 5 9 0 4 1 3, and this would be we will multiply negative inside. We will get here minus A is equal to, you see here now, it is minus 3 plus 2 minus 4 5 minus 5 minus 9 0 minus 4 minus 1 minus 3. This would be the negative of matrix A. Okay, so it is the negative matrix of matrix A. So we have seen these all the negativity, negative of a matrix, transpose of a matrix. Now I would like to tell you some operations of this. Okay, so some operations of this I would like to tell you. First we see some operations here. up and down. Now we see the operation of matrix here. Operations. Of matrices, which is the plural of matrices. So now we see here the operation, the summation, addition and subtraction operation. We see here addition of matrix. Okay. In addition, we see if we have a matrix A, the condition for this is the order must be same. Order of matrices must be same. This is the condition for addition and subtraction. If there is a order of matrix 2 by 3, other should be 2 by 3. If it is 3 by 2 or is this some other order, then we could not add these or subtract these, because the corresponding elements we have to add up and we have to subtract. Okay, as I explain you here, you see in this just like this one, A, we have a matrix. I put the elements here: 2, -3, 5, 4, 7, 0. So this is the matrix A, and we have another matrix B. Matrix B, which is 5, -9, -2, 4, 0, 7. This is our matrix B. Now we have to add it up. So we see that matrix A plus matrix B, matrix A plus matrix B. What we have to do here, we have to add the elements, corresponding elements. We have to add it up, only the corresponding, the first element with this first element we have to add 2 plus 5. Okay, we are adding this: -3 plus -9, -3 plus -9, and 5 plus -2. Okay, so in this way we have to add it up: 4 plus 4, 7 plus 0, and 0 plus 7. So in this way we have to add it up. Okay, now the next thing, we have to simplify these all, and we will get A plus B is equal to, now you see this one is 7, 2 plus 5, 7, -3, -9, -12, 5 -2, 3, 4 plus 4, 8, it is 7, it is 7 now. So we get here A plus B 7 -12, 3, 8, 7, 7. It is clear now. I think that it is the addition and the summation. And if we have to subtract A minus B, if we have to find out, I explained through this formula again. We have to find out the A minus B now. A minus B. So you see here A minus B. So we have to 2 minus 5. 2 minus 5 minus 3 minus -9, 5 minus -2, 4 minus 4, 7 minus 0, 0 minus 7. So in this way we will get this thing. Now we simplify this. So A minus B would be, see here, 2 minus 5 minus 3 minus 3 plus 9 plus 6 minus 3 plus 5 plus 2, 7, It is 0, it is 7, it is -7. So in this way, we could easily find out the subtraction of two matrices. The condition is that the orders of both the matrices should be same. Then we could add it up or we could subtract it. Now, I would like to tell you about some other sort of matrix, symmetric matrix. Symmetric matrix. So what is symmetric matrix? We see where the matrix A, where matrix A is equal to transpose of A. If matrix A is equal to its transpose, so it is called the symmetric matrix. I give you an example. You see here, if we have a matrix, just I change the color, green color. A matrix we have, see here the elements we put here, 2, -5, 4, -5, 6, 9, 4, 9, 7. This is a matrix we have, and we see here, we find out the transpose of this. So what would be the transpose of this? We see here, so A transpose, I have already explained you how to get the transpose of a matrix. We just have to convert the column into row and the row into column. So we get here, we convert this row into column. So 2, -5, 4, this row into column, -5, 6, 9, this row into column, 4, 9, 7. So look at both the matrices. If there are any difference in these two matrices, first element is 2 here, second one is -5, third one is 4. And the second row, you see the first element -5, second element 6, and third one is 9. And here also in the third row, 4, 9, 7, 4, 9, 7, both the matrices are same. Equal matrix are both. So you see here, so this matrix A is called symmetric matrix. So it is called the symmetric matrix. Now we see the skew symmetric matrix. Skew symmetric matrix. In skew symmetric matrix, I explain you first. I put one matrix here, A, 0, -9, 3, 9, 0, 4, -3, -4, 0. So this is a skew symmetric matrix. In skew symmetric matrix, the main thing is that the diagonal, the value of the element of the diagonal would be always 0. So it is the what is the definition of the skew symmetric matrix? I would like to explain you. If a negative of any matrix is equal to the transpose of that matrix, then matrix A is skew symmetric matrix. So we see, first we find out the negative of A. So we get the negative of A in this way. So minus A, I have already explained you how we have to get the negative of a matrix earlier. So if we negative multiply in whole the elements, we will get here 0, 9, -3, -9, 0, -4, 3, 4, 0. So this is the negative of A. And we have to make the transpose of A also. So we say the transpose of A, we get here 0, we have to convert this row into column, -9, 3, 9, 0, 4, -3, -4, 0. So we have made this the transpose. Now you compare this both. You compare this. So the first element in first row is 0, second is 9, third one is -3, and the second row -9, 0, -4, and the third one is 3, 4, 0, 3, 4, 0 here. So both the matrices, the negative of A and the transpose is equal. So A is a skew symmetric matrix. A is a skew symmetric matrix. Now we have seen that the symmetric matrix and the skew symmetric matrix, and now we have to find out if there is a matrix and we have to make the skew symmetric matrix or the symmetric matrix with the help of that matrix, how we would make it. So now I explain you how we would make a matrix, a skew symmetric matrix through a matrix. If you have to make the skew symmetric or symmetric matrix, it should be square matrix always. So I explain you, we have a matrix A, whatever matrix you can take here, there is no foundation that particular matrix we have to take. So 2 minus 3 4 0 9 7 4 1 6, this matrix we have taken here. Now we have to make the symmetric matrix from this one. So what we have to do, we have to make A transpose. Okay, in A transpose you see we have to convert the row into column and the column into row. So 2 minus 3 4 0 9 7 4 1 6, we have make it. Now we will add these both, A plus A transpose. So we get here, now we see what happens. We add it, 2 plus 2 minus 3 plus 0, 4 plus 4, 0 minus 3, 9 plus 9, 7 plus 1, 4 plus 4. The corresponding elements we have to add up, 1 plus 7 and 6 plus 6. So we see what happens here. Okay, so it is equal to, now you see here, it is 2 plus 2 4 minus 3 8 minus 3 18 8 8 8 12. You see here that the symmetric to this diagonal, this matrix is symmetric to this diagonal. Okay, you see here minus 3 minus 3 8 8 8 8. So it is the symmetric matrix. Now if you make the transpose of this one, and you will get the same A plus A transpose. Okay, so this is the symmetric matrix. Now if we have to make the skew symmetric matrix, so what we have to do, it's very simple to make the skew symmetric matrix of a matrix. The same way we could make it. So I explain you here. We have to subtract this A minus A transpose, we have to do. Here we have to add it up, now we have to subtract this, we just have to subtract it. So I put here we will get comfortable to do this thing here. So A minus A transpose, we have to subtract this. So we subtract those, 2 minus 2 minus 3 minus 0, 4 minus 4, 0 plus 3, 9 minus 9, 7 minus 1, 4 minus 4, 1 minus 7, 6 minus 6. So we see what happens now. 2 minus 2, there is 0, minus 3, 0, 3, 0, 6, 0, minus 6, 0. So this we have got, it is the matrix we have got here. This is the diagonal or 0, and you see here minus 3, here is 3, the opposite sign must be there in, and 0 0 6 minus 6. So it is the skew symmetric matrix here, it is the symmetric matrix here. The symbols are also same here. Here the symbols are opposite symbols should be there on the opposite side of the diagram. Okay, so this is the skew symmetric matrix we could make through a matrix, or the symmetric matrix we could make through the matrix. In this session we have studied lots of about the matrices. In the next session we will see how to multiply the scalar multiplication and matrix multiplication of the matrix. Okay, thank you.